Industrial cleaning operations don't get much more high risk than this. Behind these heavy hatches lies an environment where the most lethal threats are invisible. The greatest danger in these operations rarely comes from the physical space itself. It comes from complacency. It's the worker who has climbed down the exact same ladder for years without a single incident, assuming today will be exactly the same. Work health and safety regulations define a confined space by a few strict parameters. It's an enclosed or partially enclosed area with restricted entry or exit that was never designed for continuous human occupancy. Some of these spaces are obvious. Towering agricultural silos and massive chemical storage tanks clearly fit the criteria. But facility managers routinely overlook the hazards hiding in plain sight. Subsurface drainage channels, oversized equipment housings, and cramped ceiling voids all carry the exact same lethal potential. The true danger of industrial maintenance is the assumption that a familiar space is a safe space. The risk profile of a confined space is dictated by three specific atmospheric conditions: flammable vapors, oxygen deficiency, and the silent accumulation of toxic gases. This animated diagram illustrates how these invisible hazards stratify inside a deep drainage pit. Because gases have different densities, lighter compounds rise to the top, while heavier toxic gases separate and settle heavily across the floor. You could test the air directly at the entry threshold and get a completely safe reading, only to step down a few feet and walk directly into an immediately dangerous atmosphere. Hydrogen sulfide is a prime example. It is entirely invisible, heavier than air, and accumulates rapidly in those unseen lower levels, where it can incapacitate a worker almost instantly. To survive a confined space operation, you must abandon basic human intuition. You have to treat the air itself as a hostile, dynamic entity. Neutralizing these invisible threats requires a rigid, multi-stage protocol long before anyone physically opens a hatch. It starts with a safe work method statement, a legal document outlining exact hazard controls for the specific space being entered. Next comes continuous testing. This data chart shows what a 4-gas monitor tracks in real time. It measures precise levels of oxygen, lower explosive limits, hydrogen sulfide, and carbon monoxide, alerting the team before any metric crosses that red hazard threshold. Looking at this top-down map, you can see the mandatory 3-person structure required by law for an entry. The entrant operates inside the central hazard zone. The standby person is locked at the threshold, and the entry supervisor oversees the entire outer perimeter. That standby person holds absolute authority over the operation. They continuously monitor the entrant and are equipped to immediately initiate rescue protocols using attached retrieval lines the second a situation degrades. In high-risk environments, survival is not a personal trait. It is the direct result of a rigid, fail-safe structural system. Only when the monitoring equipment mathematically proves the space is safe does the physical decontamination phase begin. Inside these spaces, crews face severe industrial residues. For stubborn, baked-on proteins inside food processing tanks, the team deploys long-reach heated water lances. This applies sustained high-pressure force to the walls without forcing the worker to stand directly underneath falling debris. In below-ground pits, they run parallel industrial vacuums with heavy-duty HEPA filtration. This system safely extracts tons of accumulated toxic sludge and chemical precipitate that has been building up for years. While extraction happens, ventilation systems actively dictate the air patterns. This tank schematic demonstrates how forced supply and extraction points create a sweeping through-flow. This continuous breeze aggressively pushes contaminated air away from the human entrant. Even with ventilation, chemical reactions during cleaning can rapidly alter the atmosphere. The rule here is uncompromising. If a gas alarm sounds, the entrant aborts the mission and exits immediately, regardless of how close they are to finishing the job. Industrial decontamination is a continuous engineering problem, constantly balancing maximum cleaning force against volatile atmospheric data. When a facility manager hires a specialist team for confined space entry, they need to understand exactly what they are purchasing. This stacked bar chart breaks down a baseline cost of around $3,370 for a standard single tank entry. That figure accounts for the comprehensive risk assessment, mandatory permits, continuous atmospheric monitoring, and specialized waste removal. Compare this comprehensive life safety operation to a standard factory janitorial service, and it becomes clear how dangerously inadequate a simple mop and bucket approach would be in these environments. For tanks that previously held flammable or combustible liquids, strict AS 1940 compliance comes into play. This standard dictates specific gas-freeing protocols that must be executed and verified before a cleaner even approaches the space. The price tag of professional intervention is an investment in absolute risk elimination. It shields the business from catastrophic liability. The linchpin of this entire operation is the formal confined space entry permit. It functions as both a real-time safety checklist and a long-term legal shield. Once signed off by the supervisor and the standby person, these meticulously closed-out permits provide a highly defensible compliance record for the client's mandatory workplace health and safety audit files. The ultimate goal of every entry is straightforward: zero safety incidents, total regulatory compliance, and a completely decontaminated facility. Facility managers must act proactively. Book a comprehensive site assessment today to identify the hidden confined spaces in your building before an invisible hazard becomes a fatal reality. In high-risk industrial environments, you cannot outsource the liability of a fatal mistake, which is exactly why you must outsource the expertise.